Well, thank you very much for being here. I didn't expect that many people. That's cool. Alright, so basically I'm going to talk about, very broadly about all the APIs that exist to handle audio on Android. So you may know some of them. Hopefully I'll teach you a few things. I will not go into a lot of details about all of them, but at least you'll have a good idea of the landscape of sound handling over there. Just for me, quickly, my name is Yannick. I'm an Android developer. Been doing that for a few years. I'm also an organizer at the GDG Brussels. If you ever want to speak and go through Brussels, hit me up. I'm also a host for Android Leaks, which is a podcast, a French podcast about Android development, with that guy over there, which has a T-shirt with the logo on it. I'm also a noisemaker in general. I play drums, so I like to actually make a lot of noise, which is probably why I'm talking about this now. Another thing, a little disclaimer, I am absolutely not a visual designer whatsoever, so I apologize in advance for the crudeness of these slides that I'm doing. But be assured that no designer were harmed in the making of these slides. Alright. When I studied this talk, I was trying to figure out how to actually start this and how to introduce this. And I like examples, and so I figured, alright, let's see what kind of an example can I give you to actually walk through all this. And I started thinking of the beginning of smartphones. When we first had app stores, or Android market, as it were, what could you find a lot on there? Well, fart apps, really. So just type fart right now in Google Play, and that's actually a slide. That's a screenshot that's from a couple of weeks ago, and you have a lot of them, really a lot of those fart apps. And the fun part is actually some of them are actually not free. So I thought to myself, okay, how hard is it to actually make a fart app, right? So let's make one in 4 steps. All right. First is you need to create a new project in Android Studio. I'm sorry to use the actually white theme of Android Studio. I heard that it was better for slides like this. I usually don't, but anyway. Second thing, we're gonna use Kotlin because it's kind of hip and happening and it's cool. So let's make it official. Hashtag Kotlin. There you go. So now it's official. All right. Don't be afraid though if you don't know Kotlin much. There's nothing absolutely complicated about Kotlin in this code. It's really very straightforward stuff. All right, step 2. Well, we need to add a button to the automatically generated layout. Notice that I put a drawable next to the play text. That's really high-end UI for me. So that's pretty cool. We have a button. Step 3. Well, you actually need some kind of a sound to play, right? So, well, you figure out a way to record it. I'm not going to push you on that. You figure out your way. This probably can help, I don't know, whatever. Just record your very 3D surround sound system thing, and then create a file out of it. And step 3.5, put it somewhere in the raw folder. All right? So we're almost done. 1 step left. Step 4. We actually have to play that media. And to play the media, well, you need a MediaPlayer. Why not? So MediaPlayer is basically very simple to use, very straightforward. I highlighted the code in bold, so you see the MediaPlayer code. It's very simple. You create it, you give it the ID of the sound, and I have a completion listener that just when it's done playing, it will release everything, and then it starts automatically. That's all it does. Basically, it's hooked to the play button. When I hit play, it will stop whatever it was doing and then start it again. So it's very simple, and now it actually plays a fart sound that you recorded earlier, right? So this is a fart app that I made in 4 steps. Took about 10 minutes. It was great. I can put that in the store. It's awesome. And here we're using MediaPlayer. MediaPlayer, which is probably the most common sound or audio thing that we know. A few good things about MediaPlayer. So it's very simple to use, as you could tell. It was very few lines of code to actually have something working. It's been there since API 1, which is nice as well. And it handles a whole bunch of kind of resources. It can also deal with streaming, and it also can deal with DRM if you are into that kind of stuff. And by the way, it also handles video as well, not only audio, but you can just use it for audio if you want. Second thing, a few bad things is it's not really extensible, so what you have is what you get, and also you depend on OS updates for bug fixes and new features and whatnot. And also by browsing a bit the documentation, which is something that I do sometimes when I'm tired, I noticed that for Android P there's something called MediaPlayer 2, which is a great name for a new API, which I have no idea what's new in there because the documentation is a copy-paste of the MediaPlayer 1, I guess. So good job on that, Google people. So we'll see, it's a surprise. MediaPlayer 2 is coming in Android P in a device near you soon. All right. Well, there's a few other ways we can actually play this media. And another way is called ExoPlayer, which you may have heard of. And this is a code example of how to use ExoPlayer in the same exact situation. So same layout, same app, same everything. Difference is here we create a data source in a little bit more convoluted manner, but let's call it extensible. Note that I had to move the wonderful sound to a different place. I put it in the asset folder this time. Created a source media source for it. I call the prepare function with that media source, and then I just play when ready, and that's it. So same behavior. When I hit the play button, it will stop whatever it was doing and then start it over. So obviously you can do better than that, but that's basically the gist of it. And in this case, we created a player early on to just keep it around and reuse it. Probably can do that with MediaPlayer as well, but for this example, it was good enough. So that's the example with ExoPlayer. So what's good about ExoPlayer? First of all, it's much more flexible and extensible. So as you could tell, I actually in the construction early on, I gave it a default track selector, which means technically you can actually create your own track selector, whatever that does. It doesn't really matter for this example, but you can create your own and give it to it. Same thing for the media source. In this case, I use the default data source factory. You can create your own factory if you want. That actually will handle the creation of other kind of media sources, which may be more interesting for your app. So in this case, you can tell that just by this code, you can actually do much more things. Potentially, you actually can extend ExoPlayer much more than you could with MediaPlayer. So that's one of the good things about it. It's definitely better suited for more complex cases. So if you are just playing resources that are very static in a very standard way, it's probably too much. On the other hand, if you actually need things like caching or adaptive playback, you can also do composition. You can do actually a whole bunch of things that are much more complicated. A good example for this is like the usual streamed application, audio application, well, like Deezer, for instance, which is using also ExoPlayer. YouTube is using ExoPlayer. So when you actually have much more complex use cases, that's probably best suited for it. And also another very good thing is it's an external library, which means that you don't have any ties to the OS updates for bug fixing. A few bad things though. It's definitely more complex to apprehend. So it's hard to actually get into because you have a lot of options and things that probably make no sense in the beginning. It's not always as simple as it seems. It's MinSDK 16, which may not be a problem now anymore, or 19 if you need an encryption for streaming. And it's a big library, which may be a problem for some apps. But wait, there's more. Actually, I learned that. I'd never heard of it before. There's something called SoundPool, which basically is a pool full of sounds, apparently. So the idea of SoundPool is it's yet another library that exists that will allow you to load data in memory, load sounds in memory, and use them in a more efficient way. So the way it's created, in this case, we're actually using something. Before Lollipop, you just use a very simple constructor. You give it the stream type, so you say this is the kind of thing I'm going to do with this, and you give it a channel and a priority, and that's pretty much it. But that was not complex enough, so we actually they made it more complicated after Lollipop, where they introduced something called audio attributes. And the good thing about this is actually gives you much more control over what kind of media you're playing, and that's going to be much more interesting in a few things that I'm going to talk about later. But that gives you an example of how to actually instantiate a SoundPool object. And then I have, again, a complete listener to say just start playing when you're done. And then I'm loading a sound, in this case only one, which is still the awesome fart sound. And I receive a sound ID out of it. So that is just the loading part. And to actually play the sound, the few lines on top is just to figure out the volume ratio. The SoundPool play function actually takes the sound ID, which is the one I got from the loading, and then I use the volume, a few other parameters like priority, and actually interesting things like loop counts. You can actually say just loop it forever, or just loop it a few times, or don't loop it at all. And you can actually give it a speed ratio as well. You can say play it half time or play it twice as fast, which SoundPool will automatically resample the sound internally to make it fit the frequency so that it sounds like it's faster or slower. And as an added bonus, it's actually using MediaPlayer internally. So that's SoundPool. So these are the three ways, well, some of the ways that you can use to actually play sounds that are resources, kind of fixed resources, or stream, something that basically exists. Speaking of recording, which we haven't talked about much, let's see something that I've never seen in any FAR app so far is, well, let's record directly in the app. That would be awesome, right? You can actually record your own farts in your app and then play them back. You can do that with something called MediaRecorder, which basically it's a little brother or little sister, I don't know, of MediaPlayer. The MediaRecorder is actually, the API looks very similar to the MediaPlayer. It's basically you set the audio source in the output format and audio encoder. If you actually understand what that means, it's quite interesting to know. But you set those things up, and basically you're set. Everything else is pretty straightforward. You just set those things, and then you start recording. It records in a file. In this case, I actually gave it a file name. And then you can play it back quite easily enough with MediaPlayer. So in this case, it's a little bit different as the previous example. I have to actually set the data source using the file name, and then I prepare it. This can actually crash, so that's why it's in the try-catch, and then I just start. So that's how it goes if you want to actually play whatever you just recorded. So that's an overview of how you actually play sounds and record sounds in a quite simple manner. When you create an app, actually any app, that will generate sounds, that will generate audio for any reasons, there's a few concepts that you should know about. And one in particular I think is quite important. It's called AudioFocus. And AudioFocus is a way, well, it's what I call a way for your app to not be a jackass and work well with the rest of the system. The way it works is the following. Let's imagine that you have an app that starts playing music, for instance. And then you have a phone call coming in, but your app keeps playing that music. Well, that's a bit of a problem because you don't really hear, or at least you have some kind of a mashup of your music and the ringtone. And then you have someone, you actually pick it up, you try to speak to the person, and it's actually keep playing the music, so you cannot hear the person. This is pretty bad, this is wrong. So the right way to do it is, with AudioFocus, you start playing music. When you have a phone call coming in, you actually have an event that says, hey, by the way, somebody else needs the audio stuff. So you can actually pause your music. You can talk to the person, music is still paused, and then you hang up and the music starts back. That's a much better way of actually handling those things. So it's very important to actually, for any audio apps, actually for any apps that actually somehow provides audio. It can be an audio queue, for instance, anything like that. You should actually implement AudioFocus. And the way it works is actually not complicated. First, you need a listener. And the listener is the one that will receive the different events. The events are quite self-explanatory for the most part. So audio gain means you have the right of way. You can use the sound, the audio system. So basically, just play your track or reset the volume or whatever was the same before. You have the room. Second one is AudioFocus lost transient can duck. So lost transient means you are losing the focus for a certain amount of time, which is not finite, and you can duck, which means you can actually just reduce the volume because it's not going to last that long, it's not that important. And then as soon as you get it back, you will get just set the volume back up. That's the difference between lost transient, which just says, I'm gonna need the sound for a while, I don't know how long, but I need you to stop everything you're doing, but you're gonna get it back afterwards. So the interesting part about this is, an example for this is, lost transient would be the phone call. They would say, I need the full audio, so please pause. The can duck would be something like a turn-by-turn navigation that says, I'm just going to tell you where to turn, but you can continue the music if you want to. That's really up to you to figure out in your app what you need to do or what you want to do in those situations. And the last is the one that basically tells you just lost the focus, which means that if you want to actually play your data, your source again, you need to ask for the focus again. An example for this is if you do have a music player and then you start another music player or a podcast player or whatever, you will lose the focus because the other one says, I need the full focus for this. That's basically an example. So as I explained, you need to actually request the focus. It's not something that just comes to you. And the way it works is you create your focus listener, and then you call the audio manager. The audio manager is a system service, so you say context get system service to retrieve the audio manager, and then request the focus, giving the focus listener, again, the type of stream that you're using, so it can be music, can be other things, and then the type of focus you want to have. So in this case, let's imagine that I'm making a very important part app. I'm saying I want games, so that means I want everybody else to shut up. And then I receive a response, which is basically granted or not, and it's up to you to figure out what to do then. But now, if it's granted, you have the focus, you can actually play your media. That's how you actually request the focus before Oreo. Now, quickly after Oreo, again, we're using the audio attributes compat, or audio attributes in general, which they already have compat class for it, which is cool. And we explained this is content media music, content type music, and usage media as type of sound or of audio that we are providing with this app. And the way we create the request, now we actually have an audio focus request. We fill up all those information with the listener, with the type of focus that we need, and also the attributes, and then set it to the, we call it request audio focus with the request in the audio manager. So that's basically the difference between before and after Oreo. And just to give you an idea of why the content types are important, this is all the different constants that are defined right now in audio attributes compat. So that gives you basically a basic idea of all the different granularity that you can give to what sound or what audio you're gonna provide. That will help the system to figure out what's the best way to maybe automatize certain things maybe in the future, but definitely more granularity is best in this case. As often with these things, make sure that you abandon when you're done. So when you've finished, make sure that you abandon with the focus listener for before Oreo or with the request after Oreo. And something that I actually didn't stress enough previously, whether it is with the MediaPlayer, ExoPlayer, or the SoundPool, make sure that you always release at the end when you're done, because all these things actually create resources, put things in memory, and so if you keep them around, you will have leaks. So make sure that you release when you're done using them. So abandon focus is the same thing. If you keep the focus, you will receive those events forever, and then it might not be very nice. So audio focus concept in Android since API 9, I believe. So very important if you do anything with audio. So even if it's actually playing a commercial video in your app or something, you should actually implement this and make sure that you say, I'm gonna make some noise and I'm gonna have to tell everyone about it. So it's not to take lightly. All right. How about we try to make a more complex app? How does that work? Let's imagine that we want to actually make a real audio player, for instance. There are a few things that you definitely want to implement that exist in the system. One of them that you definitely assume that you're going to have, and you don't exactly know how yet, is the MediaSession. MediaSession is basically an API that will say, okay, the system will tell me when something else is telling me to pause or to play or to skip. And I'm going to relay that information to your player. That's what MediaSession. So basically it's what I say, how to control the stream from anything. So the way it works, and what is the other things? The other things can be the Android TV or the Google Assistant or your Android Wear, Wear OS by Google, sorry, and all those things. So all the external actors that actually can provide access to your media, you want to be able to let them do that. Also, it can be the notification when you actually start playing, so that you have access to that control from anywhere. You don't have to look at your app all the time. So that's basically the general schema of how it works. Your MediaSession is in between your player and your app. It's in your app somewhere. It have access to your player, and then it also listens to the system events. But this one actually doesn't really play well alone. It's using something called MediaBrowser Service as a friend to, and the way it works is MediaBrowser Service is a service, so it's really a background task. And this one is actually used to expose your media to the rest of the ecosystem. What that means is basically when you have, oh, by the way, I use ecosystem because it's a buzzword as well, so let's make it also official. Bam, hashtag ecosystem. By the way, this Anvil animation is really nice, Chet. Can you add that as a built-in animation in the Android framework? Thank you, appreciate that. So the way it works is, let's take this schema. You have those actors on the side, right? You have the Google Assistant, you have whatever, your watch, and so on. You want the watch to actually display the information about the track that is played. Eventually, it could actually show information about the next track that is in the playlist, right? The way it works, how to do that is by using a MediaSession, it's to use a MediaBrowser service. So the MediaBrowser service will expose that information, the metadata of the tracks or whatever the sound data that you are providing. It plays along with the MediaSession for everything that is control callbacks. And all this is running in the background along with your player. Whatever the player is, doesn't matter. Everything is running in the background. All that is set up so that the system can say, okay, I know what you're playing, I know what you can play, I know what you can do, pause, play, skip, whatever. And I know how to actually execute those controls. And so that everybody else can play with your tracks as well. And your app exists also and will do exactly the same thing. So it will connect the same way to the MediaBrowser service. It will retrieve the information. It will use a controller to actually control all that. But you will be able to access that information or actually display that information in a different way that makes more sense for your particular app. And so that's basically how all this is working. I didn't include any code sample because actually making a service and all that fun stuff is a bit too much for now. But basically that's the gist of it, and hopefully you can actually look it up. But let's go a little deeper now. It's actually, we have more. There's more ways to actually play or record audio. Something called AudioTrack, or the lower level MediaPlayer. The way it works is it will allow you to actually write directly a byte array of data into an audio channel. For the case of AudioTrack, the way you create an AudioTrack before Oreo, sorry, again, a constructor with a few information like sample rate, the encoding type, the number of samples, that whole bunch of things that you have to figure out for yourself or calculate. Above Oreo, again, we're using the same kind of builder system with audio attributes again, and so on, but basically it's the same thing. And now, to actually play the data, well, after having initialized the audio track, you have to get the data, the sound data somehow. For that, you can actually either read a file, that's fine. You can also generate your own sounds if you want to, which is where it gets interesting to me. And for that, you actually need another API, which is a brain API, which is called Math, which I do not have. But you can do that. You can basically generate tones and play them directly into the audio channel using the audio track. And so you give it the byte array, you give it the start offset, you give it the buffer size, and then it will just play. This can be blocking or not, so you can actually give an extra parameter, say I want this to be blocking or not blocking. So you may have to actually work that into a thread, make that may have to run that also into some kind of a loop if you need to feed it regularly and so on and so forth. So it can actually get very, very complicated, but that's a very basic gist of it. And we can definitely use this as well to play our beautiful fart sound from earlier, but that's probably a bit overkill. And we have, again, little sister, little brother, whatever, AudioRecord, which is the lower level MediaRecorder, which basically does exactly the same thing as AudioTrack, which is reading or receiving the data as byte arrays from a source. So you have to specify the audio source, and then you can do whatever with that data. It's raw data, so you can really have access to that lower level data information, which is nice. Again, I'm not going to show any code because it's very similar. Instead of write, it's actually the function is called read. Everything else is very, very similar. And also another thing, AudioTrack and AudioRecord, like it's written in the title, only does audio. It does not do video, as opposed to MediaPlayer and MediaRecorder. Another thing is called AudioEffect, which applies effects to audio, surprisingly enough. Android comes with a few built-in effects, which are listed over there. My favorite is the eco-friendly environmental reverb. Very nice. Basically, all these actually are effects that exist in the audio world. It's nothing that they invented. Those effects, you can the way it works is you create an object. You can actually create your own implementation of a new effects if you want to, as long as you follow the AudioEffect interface. And all these are predefined, so you can use it as you wish. So the way it works is you create, like in this case, a reverb. I took the preset reverb because it's easier to use a preset. So I use the preset large hole. I give it. I say that it's enabled, and then I apply it to the audio track using the attached aux effects. And I have to not forget to send your aux effects send level, so that actually some input to it. You can actually use that with MediaPlayer as well. As far as I know, you cannot do that with ExoPlayer, but I'm not entirely sure. So this is very simple to use, and those you can already use. One caveat that I noticed is that you can actually only use one effect at a time for some reason. I haven't found a way to actually use more than one. And it's kind of tricky. So if you actually look into audio effects on Stack Overflow, you're going to see a lot of people saying, I tried this and it doesn't work. Because you actually have to call things in the right order. It can be quite tricky. And the good thing about this is actually those effects are based on a standard. Because why not? There is a standard called OpenSL ES, which may look very familiar to a lot of you. If you have heard about OpenGL ES, which is basically the same company doing those things. OpenSL stands for Open Sound Library for embedded systems. Basically, it's exactly like OpenGL but for sound. So they provide a standard way to define the communication for audio and the functionality and so on and so forth. So it's really like OpenGL. All the effects types and parameters are matched to the specification of OpenSL, version 101. Current version is 1.1. So FYI, it's very important or not, I don't know. The NDK also provides an implementation of OpenSL, also based on 1.0.1. So maybe interesting to know. It's not as crucial to know those things as it is for OpenGL, but just FYI. There are a few differences from the implementation of the NDK and the actual specification, which are all explained in documentation, which is actually quite nicely done. Another alternative that is actually not a standard is called SuperPowered. It's actually an SDK, it's a C++ SDK, which is cross-platform. Works on Android, iOS, and OS X. Actually, this is much more than a specification. It's actually an implementation of a whole bunch of sound processing systems. The nice thing about this one is it's quite known in the sound world in general. It's used a lot in iOS apps already. It is a C++ library, so it's actually really cross-platform. You can copy-paste the code from one platform to another. And they have fixed latency issues a lot early on. I know. So basically, it's not easy to get into, but it's interesting, and they provide a lot of functions for sound manipulation in general. So it's quite interesting to look into that if you're looking to actually make a sound generator, for instance, or something along those lines. It actually can be useful for audio app as well if you want to add some special effects to the audio coming out or something like that. So it can be interesting. I just wanted to point it out because I think it's nice to know that it actually exists. And I have one more thing. So last but not least, to me, I think that's a very important part of the audio landscape. There actually is support for MIDI, and that's pretty cool. The MIDI basically is called Musical Instrument Digital Interface for those of you who do not know. It's been around for a long time. 1983 was the release of the specification. I was 4. I'm sure I was very excited then about this. There's a lot of instruments that are MIDI compatible. First ones are, we think of our keyboards, but also drums, guitars, probably trumpets, I don't know. There's a lot of things. There's not only instruments, there's also what we call interfaces, controllers of multiple kinds. They actually can do a lot of things. It can synchronize tempo, for instance, across multiple MIDI instruments. It's actually quite extensive what we can do with MIDI. And generally speaking, how does MIDI work? So usually you start with a controller. You connect it to an interface. I told you the slides were terrible, I'm sorry. So you connect the controller to an interface, which may or may not be a computer already. You connect the computer in the interface, and the interface is not part of it yet. And now they actually can communicate both ways, back and forth, using MIDI events. And a MIDI event is not very complicated. It's basically it's a note with a bunch of information about that note, like the velocity, maybe an effect that was applied to that note with a wheel, something like that, on the keyboard, on the controller, whatever. So basically you have a few information about that note, and the computer, let's say that the computer is actually interpreting that event, can interpret it in many ways. It can be generating a sound out of it, but it could actually also be other things. It could be actually triggering a video or something like that. It can be pretty much anything you want. And as I said, you can actually connect more controllers to the same interface and start playing, with all those things at the same time. You can really plug anything you want. And the way it works is you can actually connect those things now using Bluetooth LE, which is nice. You can also use a USB and obviously the 5-pin connector, good old 5-pin connector if you have a computer that has that, or an interface that has that kind of connectors. So that's the ways we can actually connect MIDI controllers to interfaces today. And Android Marshmallow actually really started doing a better implementation of MIDI, or at least a better support of MIDI. But before that, just don't even try. So it's really Min SDK 23. And even then, the hardware is definitely not always friendly with that. So you have to find hardware that actually works well. I know Pixelline is pretty good with that. I think the high-end Samsung phones are actually good as well. The major problem that we had before is called latency. The latency is the time it takes between the time the event is triggered and the time the output is produced. So if you play a keyboard and you hit a key and then a few seconds later you hear the sound, it's actually going to just destroy the way you play. It's going to be extremely difficult for you to follow that thing. So if the latency is high, basically it's going to be impossible for you to play your instrument. So that's starting from Marshmallow that actually fixed a problem apparently in the architecture that was preventing Android to actually handle the latency properly and provide better support for MIDI. So that's pretty cool. So that's it for me. Thank you very much for listening. I hope you learned a few things, and if you have any questions, feel free. I think we have a few minutes. All right. So any questions? Yep.
So you just said that the last implementation of MIDI in the last Android version there's less lag.
Yep.
Is it only about MIDI, or you can play sound without lag too?
Good question. So the question is, the latency fix, is it only for MIDI or is it also for the rest of the audio landscape? It's a good question. I know that definitely for MIDI, but I do not know if it's for also the same processing for the rest of the audioscape. I am not sure, so I'd rather not say anything stupid.
I have a question.
Yep.
A few years ago, actually, I presented a music player app for Android, and I worked with the MediaPlayer API.
Yep.
We touched upon the fact that in order to play a track, you need to load and prepare, and then you can actually play it. And I remember, because I haven't touched this project in years, that the error messages for the state of the player used to be very cryptic.
Still
like
the case.
Yeah, it's still the case, is it? Like
Yeah,
state minus 51, something like that.
Yeah, so basically the question is, are the error messages for MediaPlayer still cryptic? And yeah, the thing is, MediaPlayer did not really evolve. As I said, it's linked to the OS updates, and it's so the way to receive bug fixes and so on are linked to that. So it may actually be better in later version of the OS for the same app with the same code and so on, depending on how you build it and so on. So it's not the best for sure.
Yeah.
Even now, it's definitely not the best.
I think.
Any other questions? Yep.
If you want to do like mixing of audio tracks, what framework or thing would you recommend?
Yes. So the question is, if you want to do mixing of audio tracks, what framework would I recommend? It's a good question. I think it will depend on. I don't really have a definite answer because I'm not entirely sure, but I would first try with the AudioTrack system, probably, and do some math and actually combine the binaries. That would be my first attempt, at least there. I know that in SuperPowered you can actually mix things already, and so maybe also that would be a good like old build system for that. But I'm not entirely sure. I would go AudioTrack first. Yep.
So you talked about the thing that the fact that MIDI is quite is now functional on Android, but is there like any real application of this in the real world? I mean, like people who are recording music with that and using these interfaces?
Yes.
I've seen people playing with that on the first floor, but is there like any real application of that in the world?
Yeah, so the question is there any real world application of using MIDI on a mobile device, correct?
Yeah.
Alright, so the answer is absolutely yes. And I've seen a lot of performers using, one of them is called Beatman. He's a beatboxer and he's using, I think, 3 or 4 iPads to actually do live effects on his voice. So he's doing some beatboxing and he's using those iPads to record and loop and add effects and so on in real time. And it's pretty much all using sound manipulation and MIDI for triggering and whatnot. And that's using iPads because the MIDI support has been pretty good in iOS since the beginning. And so technically, because most of those artists that are using those things are using iOS based device, that shows that there's a need for it, or at least there's a want for it. I really believe that once now that we actually have proper support and we can actually push that forward on Android, more artists actually will come up and actually do things with those things. But to give you a personal example, I am a drummer. I have an electronic drum kit. I am working on an app that will connect through MIDI to my phone, and so my phone will figure out the tempo of a song so that I can play along, and it will actually synchronize the tempo with my MIDI kit and with my drum module, and so I will have the tempo in my ears plus the song at the same time, which is helpful for practicing. So that's another real world example. All right? Yep.
Do you know any MIDI library to play actually sound like on MIDI trigger events, like would play sound, like generate sound waves?
Yeah, so
on the Android device.
So the question is there any MIDI libraries that already existing to play things. Yes, there are. I don't know them, but I know they are because you don't. I mean, there are already a few apps that exist that actually play MIDI songs in the Play Store right now. Knowing one of the people actually that made one of those apps, I know that it's not always the best handled, let's say, especially if you do have some input in your app. So if it's just playing a MIDI file, that's usually straightforward and you can find libraries for it. I don't have names. But if you actually need to play a MIDI file and then add effects to it or have some kind of an input to it or an interaction with it, then as far as I heard, it's not quite there and you probably have to rework those things a bit.
Excuse me.
Yeah.
If I can maybe add, if you go to the MIDI section on the developers, Google developers, there is I think a few libraries like MediaSession, which is an application that actually plays MIDI music. There's samples for Bluetooth, there's samples for playing music, there's a MIDI keyboard as well.
That's right. So MediaSession is on the MIDI documentation page on the Android documentation site. Yeah. Thank you for that. All right. Any other questions? No. Well, thank you very much all for being here. I really appreciate it and enjoy the rest of the conference.